Okay, so in this lesson, we're going to look at finding the horizontal asymptotes for a rational function. And mathematically, we tend to write the notation for a rational function as such. Now, you can't see that very well here, so let me go ahead and just show it to you like this. So we have this rational function. Remember, a rational function is where you have a polynomial divided by a polynomial. Now, mathematically, in terms of notation, this is what it looks like. So you have a polynomial made up of terms, okay? One or more terms. It could be a monomial, a binomial, trinomial, and so on. Notice, though, that this is in descending order. So you see the exponents in, so that, remember, the degree of a polynomial in one variable is that largest exponent that you see, and we tend to put it first, to write it first in descending order. So you have n, then the next one's n minus 1, and so on. N minus 2, n minus 3, dot, dot, dot. And then you have your x to the first term, and then your constant. So remember, we always tend to put the constant last. And the same thing for the denominator, the polynomial that's in the denominator, except we use different notation. So notice the coefficients are listed as a sub n, so subscript, so sub n. The next one's a sub n minus 1. The next one will be a sub n minus 2, a sub n minus 3, and so on. And so for the x to the first term, we have a1, and then your constant. In the denominator, we have the coefficients listed as b sub n minus 1, and so on. And notice the exponents. In the numerator, the exponents are listed with the variable n. In the denominator, we use m. All right, so just to denote different polynomials. But that's the notation. That's what it looks like. For you, though, you just tend to remember that a polynomial is made up of one or more monomials. All right, and also keep in mind that the exponent of in order for the polynomial, the exponent have the positive whole numbers or 0, as in a constant. All right, so that's what this part looks like. All right, now here's how you find the horizontal asymptote, and then we're going to look at some examples. So remember the degree, so that largest exponent you see, is the degree of the polynomial. So notice the degree of the polynomial that's in the numerator is n. The degree of the polynomial that's in the denominator is m. All right, so let me remind you, the degree of p of x is n. The degree of q of x is m. Okay? So the degree of the numerator, we're dealing with one variable for these polynomials, so the degree of the numerator is n, that's the largest exponent. The degree of the denominator is m, that's the largest exponent. Okay? All right, and so you have three situations. If n is less than m, so if the degree, so this is number one, if the degree of the numerator is less than the degree of the denominator, okay, if the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is the x-axis. As an equation that's written as y equal 0. So y equals 0 and the x-axis are the same thing. All right, kind of makes sense because if you look at the x-axis, no matter where you are on that x-axis, what's that y value? That y value on that x-axis, no matter what point you choose on that x-axis, is 0. Y equals 0 in every case, no matter where you are. All right, so that's why we say that as an equation, the x-axis is the same as y equal 0. All right, so that's what number 1 says. Number 1 says if n is less than 1, if n is less than m, rather, if n is less than m, meaning the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote is y equals 0, which is the x-axis. All right, so look at an example of this. I want to show you an example before we go to number 2. So over here, notice that we have this, f of x equal 2 divided by x plus 4. So I'm going to go ahead and write that down. So f of x equal 2. All right, f of x equal 2 divided by x plus 4. All right, so let's talk about the degree. So the polynomial in the numerator, is 2. All right, that's a constant. Remember, the degree of a constant is 0. The degree of a constant is 0. All right, and the degree of, so that means the degree of the numerator is 0. So the degree of the numerator is 0. Okay, now the degree of the denominator, which is and the denominator is x plus 4. So notice the exponent here is 1, right? So the degree of the denominator, x plus 4, is 1. All right. So the degree of the numerator, remember the degree of a constant is always 0. Make sure you understand why, because I can write, make sure you understand why. Right? Why? Because I can write 2 as 2x to the 0 power. So you see that exponent is 0? X to the 0 is 1. 1 times 2 is 2. All right, so remember x to the 0 is 1. Okay, so 1 times 2 is 2. So the degree of a constant is always 0. All right, and the degree of the polynomial that's in the denominator, you can look at that largest exponent of the variable, so x to the first is 0. All right, now since the degree of the numerator is less than the degree of the denominator, right? So since the degree of the numerator is less than the degree of the denominator, the horizontal asymptote is y equals 0, or the x-axis. All right, so look at what you see here. So this is what we just talked about. So notice the horizontal asymptote. See that dotted line on the x-axis? So your horizontal asymptote, HA, horizontal asymptote, is y equals 0, or the x-axis. Now remember, the graph goes towards the horizontal asymptote and towards the vertical. See how that looks? We talked about vertical asymptotes in a previous lesson. So your graph navigates towards those asymptotes. See? And the same thing down here. Now you don't know how to graph this, but you will pretty soon. So here's the vertical. Remember how to find a vertical? That's where the denominator is undefined. So you see that negative x plus 4 equals 0. So your vertical asymptote is negative 4. But in this lesson, you're only interested in horizontal asymptotes. In the previous lesson, we talked about vertical. So the horizontal asymptote is y equals 0. So you see how the graph goes towards the asymptotes, the horizontal asymptote? Okay? All right. Now let me just remind you, remember in the previous lesson, there was a situation where the graph did cross the horizontal asymptote. So just remember, sometimes the graph does cross the horizontal, but it will never, ever cross the vertical because that's where it's undefined. All right, so there's your horizontal asymptote. The degree of the numerator is less than the degree of the denominator. Okay, so the horizontal asymptote is always going to be the x-axis, which is the same thing as saying y equal 0. All right, Now let's look at this one. So this is going to be the second situation here. All right, so we know that if the degree of the numerator is less than the degree of the denominator, all right, meaning n is less than m, then the horizontal asymptote is going to be the x-axis. Well, what if the degrees are the same? All right, what if the degrees are the same? So if the degrees are equal, so if the degree of the numerator is equal to the degree of the denominator, okay, so if the degree of the numerator is equal to the degree of the denominator, then the horizontal asymptote then the horizontal asymptote is y equal. Remember, the horizontal asymptote is a line, so you get to denote it using an equation. So y equal. So remember, all horizontal asymptotes are always y equal. Vertical asymptotes, you remember, is x equal. So horizontal asymptote is y equal. And I'm going to write it like this for right now. So it'll be y equals a sub n divided by b sub n. Excuse me, b sub m. So a sub n divided by b sub m. All right, now let's talk about what that means, okay? So look at this right here. So you see that a sub n, that's just right here, right? And that b sub n is this. All right, so what that is these are coefficients. Y'all agree? So a sub n is a coefficient of the largest exponent term right here. And b sub m is the coefficient of x to the m, right? Okay, so here's how we're going to talk about this. So the horizontal asymptote, if the degrees are the same, meaning that if n equals m, if the degree of the numerator equals to the degree of the denominator, then the horizontal asymptote is going to equal y equal, it will be y equal the coefficient of the leading term of the numerator divided by, let me go ahead and write this a little bit better, y equal, divided by the coefficient of the leading term of the denominator. Okay, now remember it says the leading term, right? So remember, leading term doesn't always mean the first term you see. The leading term, remember the leading term of a polynomial is the term that contains the largest exponent. All right, so the leading term is the one that has the largest exponent. You're going to see a situation where there in a little while where the leading term is not listed as the first term. Okay, so here's an example. All right, let's look at this one. So we're going to look at this example, and we'll go ahead and write this out. So listen carefully to our discussion. So this is example 2. So we have g of x equal x plus 4 divided by x minus 2. All right. Now, notice the degree of the numerator. So remember, it's in descending order, so this will be your leading term because that's the one with the largest exponent. So that's x to the first, and there's your constant. So the degree of the numerator is 1, right? X to the first. The degree of the denominator is 1 as well. x to the first. Since the degrees are the same, since the degrees are the same, the horizontal asymptote is y equal, all right, now here's how you find it. So is the coefficient of the leading term in the numerator divided by the coefficient of the leading term in the denominator. So let me go ahead and write out this function again. So here's what we have. Okay, and so the leading term is here, right? And the leading term of the denominator is this. Look at the coefficient of x. Coefficient of x is 1. Coefficient of x is 1. So it will be 1 divided by 1, which reduced is 1. So we get y equal 1 is the horizontal asymptote. Okay, and notice that when you look at the graph, you see the horizontal asymptote right here, the dotted line, it's at y equal 1. See right here on the y-axis at 1? So y equal 1. So y equal 1 is the horizontal asymptote. And remember, in our discussion, even with the vertical asymptotes, the graph navigates towards the horizontal and the vertical. See how that looks? All right, so here's the horizontal. See how the graph is getting closer and closer and closer to that graph? Here's the horizontal. You see how that graph is getting closer and closer and closer to that horizontal asymptote? Same thing with the vertical. Okay? All right, now in terms of graphing this, you're going to learn how to graph this. Now these are rough sketch of a graph. So all we're interested here in this course is just a rough sketch for right now. Okay, so that's your horizontal. Pretty simple, right? All right, so let's look at this example. All right, so let's just write this example for right now. Write this example 3. So example 3, without looking at a graph, let's say this is h of x equal 3x plus 4 divided by 2x minus 1. Let's just say that, okay? And so you want to find the horizontal asymptote, if any. So it doesn't necessarily have to have one. You're going to see one in a little while, but let's find the horizontal asymptote. Okay, so to find the horizontal asymptote, we look at the degrees of the numerator, we look at the degree of the denominator. So the degree of the polynomial that's in the numerator is 1. See x to the first? So the degree of 3x plus 4 is 1. And the reason you know that is because x to the first. Okay? The degree of the denominator, which is 2x minus 1, is 1 as well. And you know that because of the exponent 1 right here. All right? So therefore, since the degrees are the same, the horizontal asymptote, I'm going to call it for HA right now. The horizontal asymptote is y equal, you must say y equal. Okay, for right now, we're going to say, all right, so remember, it's y equal the coefficient of the numerator. Let me go ahead and write this over. H of x equal 3x plus 4 divided by 2x minus 1. So it's the coefficient of the numerator, the leading term rather. Okay, so you look at the leading term. So the coefficient of the leading term of the numerator divided by the coefficient of the leading term of the denominator. So you get 3 divided by 2. And so there's your answer. So that's your horizontal asymptote. All right. Let's look at this one, example 4. So let's look at example 4. So example 4. All right, what if you had f of x equal, all right, so f of x equal, and let's say this is 2x squared minus 3x plus 1 divided by 5x squared plus 6. All right. Okay. So notice that these two polynomials are in descending order. All right. So this is going to be the leading term because that has the largest exponent, right? And this is going to be the leading term because that has the largest exponent. So notice the degree of the numerator is 2, right? The degree of the numerator is 2, the exponent. The degree of the denominator is 2 as well, the exponent. So the horizontal asymptote, is y equal, and all you do is take the ratio of the coefficients of the leading term. Let me go ahead and rewrite this over so I can circle. So f of x equal 2x squared plus, minus 3x plus 1 divided by 5x squared plus 6. And so the horizontal asymptote is going to be the ratio of the leading terms of the numerator and the denominator. The coefficients of the leading terms of the numerator and the denominator. So will be 2 divided by 5. So 2/5. Okay, so there's your horizontal asymptote. So it's very simple, very simple. All right, now let's look at the third situation. Okay, so what if the degree of the numerator is greater than the degree of the denominator? So that's what this says. So if the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. Then there is no horizontal asymptote. Okay, so the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. All right, so let's look at an example that looks like that. All right, so let's look at this one. So notice we have this function f of x, which equals x squared plus x minus 12 divided by x plus 2. And notice that in both cases, they are in descending order. So this is going to be my leading term, and this is going to be my leading term. Now notice the degree of the numerator is 2, the largest exponent. Okay, the exponent of the leading term. The degree of the denominator is 1, x to the first, the exponent of that leading term. Since the degree of the numerator is greater than the degree of the denominator, there is no horizontal asymptote. Okay, so since the degree of the numerator, that's 2, is greater than the degree of the denominator, there is no horizontal asymptote. So what does a graph of that look like? Well, here's what it looks like. And look at this. So notice you have a vertical asymptote, -2. Remember how to find that from the previous lesson. But notice there's no horizontal asymptote. See, there's no horizontal. There's no horizontal dotted line anywhere. What you have, though, and we're going to talk about this later, what you have, though, is an oblique asymptote instead. All right. Now, just a warning. So just because the degree of the numerator was greater than the degree of the denominator doesn't always mean you're going to get an oblique asymptote. If the degree of the numerator is greater than the degree of the denominator, all I'm saying for right now is that there is no horizontal asymptote. Here's an example. And in this example, though, what you ended up with was not a horizontal asymptote, but an oblique asymptote. An oblique asymptote only occurs in certain situations, and we're going to talk about that next time. All right. Okay, so those are the three situations that I wanted to talk about. So let's look at some examples. Actually, before we do that, let's look at this right here. So just to remind ourselves. So look at this graph right here. So you see the degrees are the same, right? The degrees are the same. Look at the ratio of the coefficients. So the horizontal asymptote, all right. So will be y equal, right? Y equal. Now what is the coefficient of that leading term? The coefficient of that leading term is 3 in the numerator. What is the coefficient of the leading term in the denominator? The coefficient of the leading term in the denominator is 1. What is 3 divided by 1? 3 divided by 1 is 3. So my horizontal asymptote is y equals 3, and you see that it is. Okay, so there's your horizontal asymptote. And notice that the graph, and I didn't do a very good job graphing this, but notice that the graph gets closer and closer to the horizontal asymptote without touching it. Graph gets closer and closer to the horizontal asymptote without touching it. All right, now sometimes the graph can cross a horizontal, but not in this case. The graph will never, ever cross a vertical because that's where it is undefined. All right, so that's that one. Now let's look at this one. So look at this. So notice the degrees are the same, right? The degree of the numerator is 1. The degree of the denominator is 1. So the degrees are the same. So the horizontal asymptote will be y equal. All right, now it's a coefficient of the leading term in the numerator. So that's 6. Divided by the coefficient of the leading term in the denominator. So that's 2. 6 divided by 2 is 3. So your horizontal asymptote is y equals 3. And notice what you see. See, the graph gets closer and closer to y equals 3. So y equals 3 is the horizontal asymptote. Same thing here. On this side, the graph, as it goes to the left like this, the graph gets closer and closer to y equals 3. All right, so in terms of the graph, that's what that looks like. Okay, so now let's look at some examples though. So let's look at the examples and then see, it's not very difficult. So let's just look at these. Okay, so find the horizontal asymptote for each rational function, if any. All right, so look at number 1. So think about what we discussed. So notice the degree of the numerator is 0, right? So the degree, so I'm going to put number 1 here. Let's do number 1 here. So this is number 1. Okay, so g of x equal -4 divided by x plus 8. So you ask yourself, what's the degree of the numerator? Well, the degree of the numerator, I'm going to abbreviate here, is 0, right? Because that's a constant. The degree of a constant is 0. The degree of the denominator is 1. The x to the first. So that's 1. Okay? Since the degree of the numerator is less than degree of denominator, I'm abbreviating quite a bit here, then the horizontal asymptote is y equal 0, or the x-axis. Now, if it says write the horizontal asymptote as an equation, you must say y equals 0. All right, if it doesn't say that, then you can say the x-axis. So be answer. You can say y equals 0 or x-axis. All right, number 2. All right, number 2, we have this for number 2. We have h of x. All right, h of x is 2x minus 1 divided by x plus 5. All right, so look at the degrees. So the degree of the numerator, so the leading term, is is 1. Degree of the numerator is 1. So the degree of numerator is 1. Degree of denominator is 1 as well, right? X to the first. So the horizontal asymptote then will be y equal the coefficients of those leading terms. So the coefficient of the leading term in the numerator divided by the coefficient of the leading term in the denominator. So 2 divided by 1, right? So 2 divided by 1, which is 2. So you don't leave it as 2 divided by 1. Say 2. So the answer will be y equal 2. So here the answer is y equal 2. So that's your horizontal asymptote. Number 3, let me go ahead and rewrite number 3 over. So you have k of x is equal to x plus 6 divided by x squared minus 25. So 3, k of x equal x plus 6 divided by x squared minus 25. So again, notice the degree of the numerator is 1, x to the first, the largest exponent. So that's going to be your leading term right here. And the degree of denominator is 2, right? Okay. Since the degree of the numerator is less than the degree of the denominator, then the horizontal asymptote will be y equal 0 or x-axis. All right, so the answer for number 3 is y equals 0 or same thing as the x-axis. All right, number 4, I'm going to write number 4 right here. So number 4, this was our problem. We have f of x equal x squared minus 6x plus 1 divided by x plus 4. All right. So notice it's in descending order. So this is your leading term and this is your leading term. So the degree of numerator is 2, x squared. So 2. The degree of denominator is 1, x to the first. Since the degree of numerator is greater than the degree of the denominator, then the horizontal asymptote is, there is none, right? So you're going to say none. Okay, so there is no horizontal asymptote. Okay, so no horizontal asymptote. So for number 4, you're just going to say none. All right, none. So there is no horizontal asymptote because the degree of the numerator is greater than the degree of the denominator. All right, number 5. Here's number 5. We have h of x is equal to 3x squared minus 7x, and then the denominator is 2x squared plus 3x plus 1. All right. So notice it's in descending order in both cases. So there's your leading term, there's your leading term, okay? So the degree of numerator is 2, x squared, 2. The degree of denominator is 2 as well, x squared. The degrees are the same. Since the degrees are the same, equals, since the degree of the numerator equals the degree of the denominator, then the horizontal asymptote is y equal, and all you do is look at the coefficients of the leading term. So 3 divided by 2. 3 divided by 2. So there's your horizontal asymptote. So number 5, you're going to say the answer is y equal 3 divided by 2. Okay? All right, number 6. All right, number 6 you have this for number 6. All right, you have f of x equal 2x squared minus x plus 2 divided by 5x plus 3x squared minus 1. All right, now be a little bit careful there. So some students seem to think that the leading term is that first term they see. That's not the case. Remember, the leading term is a term with the largest exponent when you have one variable. So the leading term is the term with the largest exponent. Okay, so notice that in the numerator is in descending order here, but the denominator is not. So you may want to rewrite this. So 2x squared minus x plus 2 divided by 3x squared plus 5x minus 1. So now these are your leading terms. Okay? So notice that the degrees are the same. The degree of the numerator equals the degree of the numerator, which is 2, equals the degree of the denominator, which is also 2, right? So since the degrees are the same, then the horizontal asymptote is y equal the coefficients of those leading terms. So 2 divided by 3. All right. Now, real quickly, I just want to make sure you understand something else. So let's suppose that g of x was, let's say, 8x plus 1 and divided by 12x minus 2. All right. So I just want you to understand that if the degrees are the same, which they are here, 1 and 1, the horizontal asymptote make sure you reduce. So you're going to say y equal 8/12, but reduce that. So 8/12 reduced is going to be 2/3. So the answer, you're going to say y equal 2/3. All right, just make sure that if you have that situation that you end up reducing. Okay. All right, so that is our study on finding horizontal asymptotes for a rational function.